This video is part of an online course of Calculus 1, and I'm going to talk about trigonometric identities. Well, I'm going to start with this one. Sine of any x plus 2 pi is equal to sine of x, and cosine of any x plus 2 pi is equal to cosine of x. Basically, if you add 2 pi to your angles, then sine of cosine would be the same. For example, sine of 2 pi plus pi over 4 is equal to sine of pi over 4. For example, cosine of pi over 6 plus 2 pi is cosine of pi over 6. Basically, if you add 2 pi to your angle, then it means that you're not going to change the function because this is the period of sine and cosine. Then the second identity is that sine of x is always less than 1. So absolute value of sine of any angle is less than 1, which means that sine of x is always between -1 and 1. This is also true for cosine of x. So cosine of x, for any x that you put inside cosine, is between -1 and 1. Okay? The third identity is the very important one. Sine square of any angle plus cosine square of the same angle is equal to 1. So we say sine square plus cosine square for any angle, for any x. For example, if you put pi over 6 for both of them, if you add sine square plus cosine square, you get 1. Okay? Then we have tan of x, which is equal to sine of x over cosine of x. Cotan of x is cosine of x over sine of x. Okay? Then we have 1 over sine x, which is equal to cosecant of x. It is the name of it. The cosecant is another trigonometric function, and we define it as 1 over sine of x. For example, if I ask you what is cosecant of pi over 2, you say cosecant of pi over 2 is 1 over sine of pi over 2. Sine of pi over 2 is 1, so cosecant of pi over 2 is going to be 1. There is another trigonometric function that is called secant of x. So secant is going to be defined as 1 over cosine of x. So secant is cosine, 1 over cosine. Cosecant is 1 over sine. Okay, what else? This is number 4. I'm gonna tell you about the double angle formula. So double angle formula. And what are they? Sine of 2x is equal to 2 sine x cosine x. And cosine of 2x is equal to cosine square of x minus sine square of x. Okay, for example, if I say, what is sine of 2 pi? You say sine of 2 pi is equal to 2 sine of pi cosine of pi. Okay, so something like that. Then I'm gonna tell you about addition and subtraction. So addition and subtraction formulas, and what are they? Sine of x plus y is going to be sine of x cosine y plus cosine x sine y. If you have sine of x minus y, then it would be the same thing, but you have a minus sign in here. And then we have cosine of x plus y. it's equal to cosine x, cosine y. Okay, you see the difference if you want to memorize them. So cosine x, cosine y minus sine x, sine y. And then if you have a negative sign in here, it's going to be plus in here. Okay, good. What else? Let me go to number 5. And you see, sine of x is equal to 0. What are the angles whose sine is equal to 0? The angles are going to be integer multiple of pi. Okay, so for example, what? It could be pi, sine of pi is 0, then sine of 2 pi is 0, sine of 3 pi, sine of 4 pi, etc. What do we have for cosine? Cosine of x is 0 if and only if x is equal to integer multiple of pi plus pi over 2. Okay, so n is an integer. What do I mean by that? I mean this. If x is pi over 2, cosine of that is equal to 0. If x is pi plus pi over 2, which means that it is 3 pi over 2, then cosine of that is equal to 0. Then if I have 2 pi plus pi over 2, which is equal to 5 pi over 2, then cosine of that is 0. So basically pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, all of them, their cosine is equal to 0. Very good. Then let me talk a little bit about Cotan function. So Cotan, actually, no, I didn't want to talk about this. I wanted to talk about tan of x. So tan of x, I said that it's sine x over cosine x. So the domain of it would be equal to what? Would be equal to all x such that, as you see, it's a fraction. I don't have any problem in here. I have a problem in here. Denominator cannot be 0. So all x such that their cosine is not going to be 0. So cosine is 0 where? At these points, right? So if x is not equal to, let me just tell you something. I can rewrite this as n plus 1, actually, no, 2n plus 1 I meant. 2n plus 1 times pi over 2. So n could be 0, that's why I get pi over 2. N could be 1, that's why I get 3 pi over 2. N could be 2, I get 5 pi over 2. So n plus 1, so 2n plus 1 times pi over 2. X naught shouldn't be that, because at these points cosine would be 0 and they are not on the domain of that. And the range of tan of x is all real numbers r, and tan of x plus pi is equal to tan of x, because pi is the period of tan. Okay, these are all the trigonometric functions, and we wanted to talk about the important ones are this one, the first one in here, and these functions. The rest are really good that if you know for this course.